all, we're going to open the database that we already made. So create part 2, then we click OK. Now we go to group, create a new group name. We name it FEM surfaces. We check make current, apply, then cancel. Now we're going to mesh it. Now we go to mesh, create mesh, quad, iso quad, mesh quad. We put in paver hybrid, surface list. We're going to select everything. Automate calculation, we are going to display it and just click 1. Now we click apply. Now it's meshed. Now we go to equivalence. Equivalence all tolerance cube. Equivalence tolerance is going to be 0.005 and we only hit apply. Since we have the student version, we have to modify the mesh. On value, we're going to put it at 2 and then we hit apply. Now we can continue. Now we go to equivalence. Now to 0.005, then apply. Everything is okay. Now we're going to verify element boundaries, free edges. We click apply. Everything is okay. Now we're going to verify the quad. All. We're going to aspect. It's already in aspect ratio 5. We're going to apply. We go to group, then post. Select all surfaces, then apply and cancel. Then we put the smooth surface, smooth shaded surface. Then we are going to zoom on this area specific. Wait, on this area. Now we're going to create a force. We go to load and boundary conditions, create force nodal. We name it as dead force. Dead force or dead load. We select input data. Then it will be 0 minus 150, 0, click OK, and to click application region, we are going to make sure that it's in geometry, and we're going to select point 3 and 60. We click add, then OK, then apply. Now the load is positioned. Now we're going to position it right here. We're going to set a new load, create force nodal, dead load number 2, input data, and it's going to be minus 960. Click OK. Now select application region. We make sure it's in geometry. We select point 30 and it was point 37 and point 80. We click on add, OK, then apply. Now the load is charged. Now we're going to add a new load, and it's going to be called OP static load. Input data, we're going to minus 100 on Y and minus 100 on X. Click OK. Select application region. We make sure that it's in geometry. We choose point 37 and 80. We add, OK, then apply. Now we see there are two loads that this may appear that are vertical like this, but if we turn it around, we can see that they are a little bit inclined. Now we're going to create force, but it's going to be an inertial load. We're going to name it gravity. Now input data, we're going to put 0 minus 386.4 and 0, OK, then apply. And now gravity is created. Now we go to create displacements nodal, new set name, fixed base, input data, 0, 0, 0, OK, then select application region. We make sure it's select geometry, and we are going to select points, point 1, point 1, point 52, point 90, and 98. Click on add, OK, then apply. Now it is fixed on these 4 points. Now we go to display low element properties. Then we going to check show LBC element properties values. We click apply and cancel. Now we are going to properties, isotropic. We're going to enter material name as aluminum. Input properties, elastic models is going to be 10 power to the 6th. Boson's radio it's going to be 0.3, and density it's going to be 2.61 exponential to the minus 4. We click OK, then apply. Now the material aluminum is created. Now we go to properties, we go to create, then 2D. In this case it's going to be a shell. create 2D shell. On property set name, it's going to be called all frame flange. Input properties, we're going to select the material we already created, aluminum. On thickness, we are going to put 0.75. Click OK. Now we're going to put the front view, and we're going to click on preference, peaking. Here we're going to choose enclose entire entity. Select application region. We choose the top. Wait. Choose all the top surfaces. Click add. And all the bottom surfaces. Click them add. Then OK. Then apply. Now we apply it. Then we just go to property set name, all wheel frame, input properties with just aluminum, thickness 0.5, it's okay. And select application region, we just select all the web where is the holes, then we click apply. Now we go to load cases, now create, now default. Here it is everything. That pops up a window and shows everything. We just make sure everything is selected. We click cancel. Then we are going to do the next step. Now we go to group, post. Under select group posts, we select FEM surfaces, apply, then cancel. Now we are going to run the analysis, entire model, full run. To create a solution type, it's going to be linear static, solution 101. Okay, then we hit apply. Now it is. Now we go to results, analysis. We put XDV, attach XDV result. We click apply. Attach results flat. Now we go to results. We go to stress tensor, placement, stress tensor, displacement, transactional, apply. Then we have the results here. And that's it for this one. Now we click on create deformation. Then we click